All right, hey guys. Today we're talking about inverse trigonometric functions. Inverse, meaning inverse, not negative or reciprocal. Inverse.
Yeah, we're going to look at that funny -1 exponent. Okay.
And trigonometric stuff. So,
all right. So let's recall a few things. A function's inverse is a function only if the function is 1-to-1. And remember, that was where we crossed the horizontal, past the horizontal line test.
and the vertical line test. Function, vertical, if it's 1-to-1, it's horizontal line test too.
All right, so first thing we're going to do is sketch the sine function. Okay, so let's sketch the sine function.
Okay, let's see. Here's, this will be
Pi over 2.
pi over 2. This is pi. This is 2 pi. This is 3 pi over 2.
Keep going this way, please. Negative pi over 2.
Negative pi. Negative 3 pi over 2. Negative 2 pi.
And you just had a test on this, so this shouldn't be a problem. So let's just sketch it. We need our amplitude point.
Here's 1. One to -1. So we've got maximum to 0 to minimum to 0, like that. And then on the other side, over here, there.
Okay. Now, do you remember that what we said before when we were working with the calculator and the question was, well, how do we know which 0 to pick? How do we know which thing that, when we were trying to figure out which one do we pick when we're looking on the calculator and we're finding all the solutions? And we said, well, for right now, just pick the one closest to the y-axis, but that's not really how we do it. Today, we learned why we actually have to pick a specific interval for our answer. And it just so happens that it correlates to what your calculator is programmed to give you. All right, if you notice this sine function here, it is not 1-to-1. This is not 1-to-1. That's because if we drew a vertical line, it is possible to draw a horizontal line, that would intersect it at more than one point. But is there, and you will notice that all of our values for sine, our sine values, are all between -1 and 1. So is there a portion of this graph that we could pick where every single possible value happens for sine? Every value. And what I want to do is get that portion as close to the origin as possible. So if we pick this interval, well, that doesn't give us negative values and it repeats positive values, so we don't want to pick that. Okay? So that's not a good interval to pick. Let me re-sketch our sine graph here. Okay, so where could we pick every single value that occurs? Well, if you notice, if we look from negative pi over 2 to pi over 2, every possible value for sine occurs there. Okay, that is going to be what we call our restricted domain. So now we have to give our answer when we are looking for something. We have to look at our answer between negative pi over 2 and pi over 2. All right, and so what we're looking at here is, okay.
It's fine.
All right, so do you notice that if we are looking in this interval, we are talking about quadrant 1 values, and from negative pi over 2 to pi over 2, while it doesn't really look at it like it, this is quadrant 4. If we go to the unit circle, notice that on our unit circle, our sine values are positive here in quadrant 1. Oopsie. And negative here in quadrant 2. And quadrant 4. Goodness gracious, it's the end of the day and we're tired. Okay. So we have to notice, though, that yes, quadrant 4 is 3 pi over 2 to 0, but it is also 3 pi over 2 to 2 pi, but it is also negative pi over 2 to 0. So what we are looking for here is we are going to restrict our interval for sine between negative pi over 2 and pi over 2 when we are looking for an angle where we know the value of the sine. That's kind of crazy, but we will look at an example and that will help you. All right, so let's forget about what's up here for a moment. We'll come back to that. We are going to now answer the question, where do we have a value for sine? That is square root of 3 over 2. Now the first thing we want to know is how do we read this question? We read this question as find the angle whose, oopsie, can't spell, it's one thing I can't do, whose sine is square root of 3 over 2. Notice that because of this right here, that means we are looking for an angle. We have the sine value, we want the angle. So the way we think about this is, let's remember what we just saw. All of our values are between -1 and 1, and the angles that fall in that where the sine gives us a value between -1 and 1 are between negative pi over 2 and pi over 2. So if we have a positive value such as we do here, we're going to answer in
Quadrant 1.
quadrant 1. If we have a negative value, like we do in the next one, except that that's a special one, we are going to answer in quadrant 4 with that being from negative pi over 2 to 0. That's how we're going to answer this. So that's the important thing to remember, okay? So here we go. We're in square root of 3 over 2. Our y is square root of 3 over 2, so we are looking at this. This is the point. X is something, but the y is square root of 3 over 2. You ought to recognize what x is. X should be a half. What angle is that? Our angle
Pi over 3.
is pi over 3. Is pi over 3 between 0 and pi over 2?
Yes.
Yes, it is. So we have answered correctly. Now, here's the question. Would it have been wrong isn't the sine of 2 pi over 3 also square root of 3 over 2?
Yes, but it's not in our interval.
Yeah, if we go back and look at the previous graph, yes, 2 pi over 3 is over here somewhere, okay? Yes, our value is square root of 3 over 2 there, but we have to answer our positive values must come from quadrant 1, okay? So if you were to go to your calculator, and do inverse sine and see which angle it gives you, it is going to give you only the pi over 3 one. Now let's look at the next one. We want the angle whose sine is -1. Once again, it's useful to think about what are we talking about. Sine, where is sine -1? Remember, sine is y over r. That's -1 down here where the y coordinate is -1. That happens at 3 pi over 2, right? Is that our answer?
No,
Why?
because it needs to be between negative pi over 2 and pi over 2,
So
which
we have-
means we have to think of it as a negative angle, which is negative pi over 2.
So our angle, the way that we have to give this is negative pi over 2. If you go on your calculator, just for grins, we don't want you to really do any of this on your calculator, but if you go to your calculator and have it do inverse sine of -1, it is going to give you negative pi over 2 because the calculator has to have a restricted domain so that it can give answers that will work, okay? All right, again, notice that that -1 does not mean reciprocal. Sine inverse of something, of some value, let's call it v, is not 1 over the sine of v.
That's bad.
Bad, bad, bad.
Bad Americans.
We would not be a happy camper with that, okay? All right.
All right, so now what we're going to do is we're going to look at what sine and sine inverse do to
You know
each
what?
other.
Pause. not pause, but really go back here. Remember we said we were going to talk about this thing in the oval, all right? So this is saying right here, for any value for your sine function between -1 and 1, we have to give our answer for our angle has to be between -pi/2 and 0. So if we have a positive sine value, we give it in the interval 0 to pi/2. If we have a negative sine value, we give it in that interval. That is very important. Okay, now go ahead. Next page.
Okay, so let's look at what happens when we take the sine inverse of a sine of a function. This is important because when you take the inverse and you plug in the function, you end up getting the input, the original value you put in. Okay? So this happens to every inverse function.
Remember when we did this? F inverse of f of x
equals
gave
x.
us x. Well, careful with the trig. Because with trig functions,
because they're periodic,
it's not always true. We have restricted values, restricted intervals. Okay? That's
so you have
important.
to pay attention to where u is and where your function is. If u is a funky value, you have to find your u if u is in between -pi/2 and pi/2.
Right, and before we get started, you also have to pay very close attention to notation. Notice that right here, this means we know an angle. Okay? And we want the sine of that angle. Okay? That's what that notation means. This notation means we are looking for an angle. Got it? That's really important. Whenever you see sine inverse, we are looking for an angle. So what does this mean right here?
We are looking for an angle whose
But
sine is v.
But what is important about that angle?
It has to be between -pi/2 to pi/2. We're looking for an angle
On the interval.
-pi/2 to pi/2. Okay, and then the outside part is saying find. We know the angle. Find the sine. Okay, so here we have an example. It says explain why the sine inverse of sine of pi/4 equals pi/4 is true, but the sine inverse of sine of 7 pi/4 equals 7 pi/4 is not true. Well,
So yeah, let's start with this side here.
we're going to start with the left side because this one is true. Well, the sine of pi/4 is the square root of 2/2. All right. The sine inverse restricts our domain between, or our range. I guess it would be our range.
Our range, yeah.
It's
the angle has
the
to be.
angle has to be between -pi/2 to pi/2.
Yeah, let me fix that. It wasn't. I didn't write that well.
And the sine of the angle is the square root of 2/2, which means our angle has to be positive because the sine is positive. So if I draw my circle,
So wait, since this is positive,
since that is positive,
we want.
the angle that corresponds to that ratio.
And where does that angle have to be?
It has to be between -pi/2 and pi/2, which is in this particular instance is in quadrant 1.
Yeah, since this is positive, our angle has to be in quadrant 1.
So if we drew our unit circle, okay, it has to be in quadrant 1. Right here is the angle that has the coordinates square root of 2/2, comma square root of 2/2. We should know that coordinate. The angle here is pi/4.
Right. Yeah. Good. Yeah. Good. You're so good.
There.
Okay, so the answer is
pi over 4.
So our angle is part of, and how do we know we were looking for an angle? Because the outside function, the one the farthest on the outside, is saying look for an angle.
All right, now let's talk about this second part. Okay, the inside section says find the sine of 7 pi over 4. Okay, so we're looking for a ratio.
Where is that? Where is the sine of 7 pi over 4?
7 pi over 4 is...
Oh, right there.
Yeah, right there. And that's negative square root of 2 over 2. Okay, it's the y value of that coordinate. So that's negative square root of 2 over 2. But the sine inverse has to be restricted between negative pi over 2 to pi over 2. Well, it's in quadrant 4, so we're okay with that. But we've got to look at it instead of 7 pi over 4, we're going to look at it as negative pi over 4. So, the angle is negative pi over 4.
But guess what? Negative pi over 4 is coterminal. You remember that word?
Yep. Coterminal with 7 pi over 4. They're coterminal angles.
But 7 pi over 4 is going to get you the wrong answer, because when we use this inverse notation, we are talking about it has to be in a very specific place. And now, when we ask you to find an angle whose sine is 1, an angle whose cosine is negative 1/2, you're going to come from a very specific place.
Okay, I have an example of a situation that this would be likened to. All right, everybody has a toaster in their house. Okay, like there are lots of different angles that have a sine of square root of 2 over 2, okay? So if everybody has a toaster in their house, and I tell you to go find a toaster, you can go to anybody's house and pick up a toaster. But in this situation, I'm telling you to go pick up a specific toaster. I want you to go pick up your toaster. So we're looking for the toaster in your house, okay? Because that's the principal one that you need to use. If you go use Miss Dockstader's toaster, she will get mad at you.
Yeah.
Okay? So, in this situation, we're looking for the values of sine, the angles that are between negative pi over 2 to pi over 2, i.e., your toaster.
Okay? So it's really important. This is not something, guys, you can be sloppy on. You cannot be sloppy.